Okay, I figured it'd be a good idea to practice some of that ionic naming and formula writing. So you can see I have three columns here. I have a name, a scrap, and a formula. Of course, the instructions are if I give you the name, you give me the formula. If I give you the formula, you give me the name. And all things considered, that's all that I look at. So when you have things like the scrap area, it's just like scrap for math, where you use it, you use it. If not, that's okay too. All right. Now, none of this is really possible um, unless you know, and you almost have to internalize. Of course, if you're in my class, you always have a periodic table, but you have to know these representative elements. And the representative elements are the elements where their charge, right, their ionic charge that they develop is dictated from their position on the periodic table of elements. And we basically have a -1, -2, -3, -4, and -5. Right? You got to remember that those go all the way down to the staircase for the most part, like so. And those are negative. In fact, let's switch over to maybe green for the positives. We also have +1 and +2. A third one would be aluminum at a +3. And of course, again, all of these negatives they march forward to become isoelectric with the noble gas. That's their ionic charge. That's how it's developed. And all of these green ones march backward also to become isoelectric to the noble gas. Now, if you're in my class, I also give you or make you know two more. I call it the reverse staircase. Zinc, aluminum, and silver at a +1, +2, +3. I know that's a little hard to see that green there, but it's directly in the reverse order. Okay, we have a 1, 2, 3. And if you're in my class, I'll tell you what, you just have to know those. You have to know them at all times. That if you're dealing with ionic compounds, you always, always, always know all of these labeled charges. And we say the rest, all of these, I shouldn't use that color. Let me switch over. The rest of these, all of these need Roman numerals or the stock method, okay, because you have to identify their charge. And the reason why you have to identify their charge is because they come in multiple oxidation states or multiple charges, right? So you're not allowed to just say iron oxide. You have to give me the charge of iron in the name, okay? So the name has to have the actual charge in it. Let's get rid of all this just so we can see the actual periodic table. So let's go back to that practice. And I'm assuming that you have a periodic table like mine already colored up. I don't want to really go back and forth. I might go a little bit, but I'm assuming you're following along with your own periodic table. If you're in my class, test or quiz, again, you get a blank periodic table. It's up to you to recreate all of this kind of in real time. Okay, so I think for the purposes of what we're doing here, I think we should stick and be consistent instead of I really like the way this goes back and forth in this staggered approach where you go this way, then you go that way, then you go this way. I think right now what I'm going to do is I'm going to take a step back and I'm going to say let's just go to the formulas right now. Okay, and then we'll do a few of those. Maybe we'll do all of those, and then we'll come back and then we'll move backward from the actual formulas to the names. All right, just so maybe we can see a pattern of how these are done. Now moving forward, for like all of the all the odds, the 1, the 3, the 5, the 7, and onward, all of these odd numbers, you have to write the formula. And the ionic formulas are built around the charges. Okay, so some of those charges are given in the name. Some of them have to come from the periodic table, but you have to be able to know the charges of things. So we'll stick with the green. You just have to know bismuth. You have to know the Roman numerals. Let's throw them on the side here. You have to know that it goes, let's say 1, 2, 3, 4, 5 is kind of with the lines. Sometimes you see them without the lines on top, the little hats and floors or whatever you want to call them. IV for 4, and then that V, I guess you want to call it a V for 5. So those are the Roman numerals that we're using. In my class, you really never go over 5, which is also nice to know because sometimes you question yourself like, oh, what's the Roman numeral of 12? It's kind of indicative of you messing up. So it's nice to know that we're only going up to 5. Okay, so the V there is 5. And, you really have to know bismuth is Bi. If not, you got to look it up. So I look it up on the periodic table, and I'll tell you what, I can go back. Bismuth is right there, all right, number 83. So I know that it's capital B, I, and then it's plus 5. Phosphide. Phosphide comes from phosphorus. Okay, phosphorus is over here. It's number 15. It's in the -3 category or column. So it's a P, -3. Now we have one more step to go, and every single one of these odd numbers all the way to the end are all going to be done exactly the same way with the exact same logic. You have to know that this is an ionic compound. It has to be neutral. Overall, neutral, no charge. And right now it has a charge, +5, -3, -3. We have to neutralize this. And the easiest way to think about this is at some point, I can have multiples of each ion. At some point, it's got to be no charged overall. The easiest way to think about that is something from math called lowest common multiple. Lowest common multiple is if you start adding a number to itself, and you take another number and you add it to itself, they're going to cross paths. What I mean by that is you could take a 3 and you could add it to 3, and you could add it to 3, you could add a 3, add a 3, add a 3, add a 3. You could take a 5, you could add a 5, and add a 5, add a 5, add a 5. But it's somewhere along the lines there, they're gonna cross paths. They're gonna cross paths at 30. They're gonna cross paths at 45. They're gonna cross paths at 60. But we're looking for the lowest spot. The first pathway they cross between a 3 and a 5, they cross at 15. I don't care about the other numbers. Cross at 15. That's their lowest spot. How do I get so I need to be +15, -13. 15, they got to be neutral. So how do I get to 15 with the bismuths? Well, I can get there easily if I have 3 bismuths. Phosphorus, well, I can get to -15 if I have 5 phosphoruses. And I like to always say, and I know some tutors and teachers like to use this whole crossing pattern here. Oh, I can bring the 5 down here. I can bring the 3 over here. Not a fan of that. Okay? Reasoning it out will pay dividends. Okay? Just understanding the whole logic of becoming neutral is really the way I would want you to think about it. All right, we're going to skip number 2. Like I said, let's just do odds. Nickel, I look at nickel and it's Ni, and Roman numeral is +2. Again, that's all given. I knew nickel was Ni. If not, you have to look it up in the periodic table. Chloride, well, I remember as Cl. If I go back over here, Cl is over here. It's -1. FYI, here's nickel right there. So I'm going to go back and use my Cl -1. Lowest common multiple, the crossing path between a 1 and a 2, the closest spot they cross at is actually at 2. Well, nickel's already at 2, so it's just Ni. I don't write a 1, but it's like Ni1. Those subscripts, right? The bottom numbers are quantity numbers. Chlorine, well, chlorine, which is now called chloride. Chlorine or chloride needs to get boosted up, needs to get doubled. To get my -1s to -2, I gotta have 2 -1s. And I have my nice new bold NiCl2. I have no idea why it's so bold, but you know what? I like it. No Roman numerals in this one. Sodium. Well, sodium, Na. And it's +1. Sometimes you see plus without a 1. Just means +1. Oxide. Well, oxygen is -2. Same logic here, and if you don't like that, I'll put the 1 there. Same logic as this one. The 1 and the 2 are going to meet at 2. Who do I have to boost up? Well, now I don't have to boost up the second one. Up here, I had to boost up the Cl's, right? I had to double the Cl's. And here, I have to do the front one. The positive needs a little support there. So I need 2 NAs because the whole idea, again, is to get to 2, to neutrality. And I can do that if I have 2 NAs. Now I have a positive 2 charge. And that will neutralize my negative 2 charge over there. Let me get rid of that. Kind of made a whoopsie there. Let's get rid of that. And now I have my actual formula. The answer is Na2O. Again, keeping with the sequencing here, let's do number 7. Lead IV4. It's all right. It's up here. Lead IV, which is 4. Okay, lead is Pb plus 4. Telluride comes from tellurium. And again, if you look that up on the periodic table, it is way over here. It's number 52. Te, well, it's -2. Okay, so Te, -2. My crossing spot between a 4 and a 2, it's at 4. Well, Pb is already at 4. I don't have to do anything. It's just 1 Pb. I'm at 4. The telluride or the tellurium, right, we call it telluride in this case, well, it needs to be boosted up. I need 2 of them. Why? Because I need to get to -4. I need to get to that lowest common multiple. So it's PbTA2. Okay. And before we move on, I want to just take point. I said that some teachers and tutors teach, or even students figure out this whole idea of swapping charges, right? Bring that number down, bring that number down. I am not a fan, okay? And you can see why it does not work here. And it just takes away from the logic. I would prefer if you logically understood how this works instead of relying on some sort of, trick. Some kind of trick or something like that. All right, so next one here would be number 9. Probably pick the pace up here a little bit to make sure we get to the other side. All right, lithium, I looked that up. It's in the first column. It's a +1. Phosphide, we've actually already seen, is -3. Meeting spot between a 1 and 3 is at 3. How do I get there? Well, I need 3 Lis, 1 P. Okay, note that once you get the hang of it, you can just see these things happening. Barium, well, barium's in the second column, it's +2. Fluorine comes from fluoride, it's -1. A 2 and a 1, they meet at 2. How do I get to 2? Ba, 1 Ba, and 2 Fs. Gold 3 sulfide. Gold is Au. Okay, don't be confusing it with Ag, it's Au. It's +3. How do I know that? Well, they told us it's Roman numeral 3. Sulfide comes from sulfur, and that is -2. A 3 and a 2's meeting spots at 6. How do I get to 6 with 2 of these and 3 of these? All right, I have to multiply my gold by 2 and my sulfur by 3. Okay, we're doing good on speed. I think we're picking it up. Okay, can just start feeling it. Of course, you kind of have to get lost here a little bit finding things. At least we know ionic compounds come positive and then negative. So you know any of the second ions are going to come from the blue side over here because it's really going to go green side then blue side. Right? So it's not that hard to find these things if you know at least if it's going to be positive and negative. Lead 3 nitride, well, I'm sorry, iron 3. Iron is Fe, it's +3, it's given. Okay, you just had to know that iron is Fe. Nitride comes from nitrogen, which is -3. What do I have to do here? A 3 and a 3 meet at 3. They're already there, and it is good to go. It's already neutral at a 1-to-1 ratio there, Fen. Scroll this thing down some more. All right. Let's do blah, blah, blah. Oh, my goodness, we're almost done. Okay. 3 more to go, and then we got to really start thinking about how to do the other ones. Okay, nickel bromide. Okay, nickel bromide's coming from bromine, Ni+2, because it says it. Br is -1. It's in the -1 column. All of the negatives, we know all the negatives, they're all from those column charges. Boost this thing up, they have to meet at 2. How do I meet at 2? Well, I just put a 2 right there. Boost up the Br, which is -1. Copper 1 selenide, And that's how it's actually pronounced. You don't say copper Roman numeral. You just say the number. Copper 1 selenide. Cu plus 1. Sometimes, again, you just see it as plus. Se minus 2. Funky looking negative there. Right? You can probably think about this one as I'm erasing. A 1 and a 2. I'll put the 1 in there. Why not? The 1 and the 2 have to meet at 2, so I have to boost up the copper. Okay, I need 2 coppers for every 1 selenium, we'll say, selenide. So it's a 2-to-1 ratio. You can see that 2-to-1 ratio happen many times over the course of this packet. Here we go again. Another copper plus 1. Copper comes in 2 forms. I think we've only seen copper 1 today. That's okay. Phosphide comes from phosphorus. Phosphide is -3. A 1 and a 3 have to meet at 3. So it's going to look exactly the same. It's just going to look like that with a 3 instead of a 2. And of course the phosphorus and the phosphide instead of the selenide. Right, so that's all of them going from the name to the formula. Now, let the games begin. I'll tell you what, kind of want to erase this, but I also want to have a full key, so I'm going to leave it be. Let's at least switch colors to maybe magical red. And maybe do this, maybe get a little bit smaller on the actual mark pen. Okay, now to go from the formula to the name. We saw that some of these used Roman numerals to indicate the charge. Some of them didn't. Huh. Well, again, if I go back to this, it shouldn't be a mystery. Okay? The ones that needed the Roman numerals are all of these guys. All of these guys need Roman numerals. Okay? All but the greens. Right? They need Roman numerals. I don't know why PD never got colored. There it goes. Okay, they need Roman numerals. And this whole first column, the more I look, the more I miss. The ones that are green don't need Roman numerals. We know they're charged. The whole idea of Roman numerals, again, is to indicate the charge of the ion. The reason we do this is basically all of these have, all these highlighted yellows, they have multiple ions available. Okay, they can develop into multiple different ion forms. So we use the Roman numeral to say, oh, no, we're not talking about iron 3, we're talking about iron 2, or vice versa. Okay, so it's a way of distinguishing what you're actually talking about. Okay, let me clear off all that yellow and go back to what we're doing here. So this logic is the yellow highlighted ones needed Roman numerals, the green ones don't. Right, so if I go back to this and do number 2, and do all the evens now. Let's read it. CUS. You have to know Cu and where it's at. It's copper. And copper's over here. It's not green. It was one of those yellow ones, one of those highlighted ones. It needs Roman numerals. So what does that mean for us? You have to figure out the charge. Okay, what I mean by that is, yeah, copper and sulfur turns into sulfide. Copper sulfide. Sure, that's just not right. It's not good enough. It's not detailed enough. You didn't give me enough. You have to tell me what version of copper. Is it copper 1? Is it copper 2? Maybe there's another form of copper. And how do we do this? Well, you don't know. It's an unknown. We don't know the metal charge. We don't know the positive. We do know the negative. And in this case, if the negative is -2, remember there's a 1 there and a 1 there. There's quantity ones. If the negative is a -2, why? Because we know all of the negatives. This negative's over here. It's sulfur. Turns into sulfide, right? It's sulfide. -2. If that's -2, well, then the copper must also be a +2 to make it neutral. We have to assume it's neutral. We have to assume that your teacher or the book or whatever wrote this as a valid formula. Right? That's just part of the assumption. So it has to be neutral. The only way it's neutral is if that copper is +2. Okay, I'm going to write it in there really small. There you go. It's +2. And again, the reason why is these -2 and the +2, the overall charge had to be the same. So far, I know that's confusing, but you have to get that skill down packed. It's not always that hard. This one, Be. Be is beryllium. I is iodide. You have to ask yourself, does this need Roman numerals? Okay, that's your first step. Okay, I kind of wrote copper sulfide up here, but the first step would be, does my copper need Roman numerals? The answer would be yes. Does my beryllium need Roman numerals? I don't know. Let's look for it. Oh, there it is, right there. And we know the charge. We know the charge of beryllium. I don't have to do any extra work for this. Okay, and to tell you the truth, I don't use beryllium that much. I just want to make sure I'm spelling it right. All we have to do is just say, all right, here it comes. Beryllium. Double L's. Yep. Beryllium, and then the iodine goes to iodide. No need for any Roman numerals of any such. It's good to go. In fact, if I was going to start doing the Roman numeral count here and say, I'm just going to use Roman numerals all the time, it's going to slow you down to the point of possibly not finishing whatever you're doing here. If it's a timed event, that's bad. Sometimes quizzes and tests are timed. Okay, and that's on you. If you spend your time finding Roman numerals, doing some work over here, you're crunching numbers and +2, -2, whatever, you're doing unnecessary work that is a waste of time. It means you're wasting time. You could be doing other things. And if you use Roman numerals, again, you don't need to use them. And you open up a window of possibly getting stuff wrong for using information that you do not need to use. Why? Because we know beryllium is 2. You don't have to tell us. You're doing these things for readers, and your reader is understanding. Okay, you have to assume they know what they're talking about, science-wise, chemistry-wise, that, oh yeah, you don't have to give me beryllium's charge. There's no choice. Beryllium's +2. It's a representative element, has no choice. Next one here is Sb, 3, and 5. You gotta say, does Sb need Roman numerals? Well, let's look. Sb is over here. It's called antimony, and it's not colored green. That means it needs Romans. It needs Roman numerals. Call it the stock method. So how do we do that? Think about it here. Well, I don't know anything about this side. I know there's 3 Sb's. That's all I know. Nitrogen I do know. Nitrogen's over here. I know every single negative. This one's -3. Okay, so if the nitrogen is -3, and I have 5 of them, well, that means I have -15 here as a charge, total charge. Okay. Well, that means I must have a +15 on this side. Why? Again, it's under the assumption that this is a real formula. Okay, you're under task. You're tasked to write the name of the formula. You have to just assume that it's written correctly. That's part of the bargain. How do we get to 15 here? The only way that's possible is if you have 3. You have 3. It's written there. If you have 3 plus 5s. So that means that my Roman numeral is 5. Antimony 5 nitride. Okay, you just have to know. KCl, the next one. Does K need Roman numerals? Let's look. Where's K? Oh, it's over here. Okay, and it does not need Roman numerals. We know the charge. All right, so if I go back, I know what K is. It's potassium. And I know the Cl's from chlorine, but now we call it chloride. No work to be done. If you start spinning the wheel, start doing some work on this, you're wasting your time and you're opening yourself up for error. You have to know how much work you're supposed to actually put into these, because that one wasn't much. You didn't have to put that much effort in. And I think we can finish the whole thing up. No, I don't have to scroll. All right, looking at the next one here, number 10. ALS, does AL need Roman numerals? That's your first thing. And I look over here. Uh-oh, I know what aluminum's charge is. That means I don't need Roman numerals. FYI, that's good. Roman numerals are hard to figure out. I don't need that. I can just say it's aluminum, as they say over in the old country. Aluminum sulfur turns into sulfide. Again, not much work here. I don't have to start, writing charges, figuring out, doing math. MgN. Does Mg need Roman numerals? I gotta look it up. Where's Mg at? Where's Mg at? Oh, it's over here. OMG, it's over. Okay, I'll stop. All right, but we know its charge is +2. So what does that mean? It means it does not need Roman numerals. Where am I at here? Magnesium, just have to write it out. Magnesium, nitrogen turns into nitride. Interesting little dot there for the V for the I, but you know what? I like it. SNO2, hopefully you can feel we're picking the speed up, and hopefully you're comfortable doing that. SNO2, SN, I remember it might be tin. I don't know. Where's tin at? It's over here. And it is not labeled green, which means it needs Roman numerals. It comes in multiple forms. All right, so what form are we dealing with? Well, I know it needs Roman numerals. Let's look at it. Well, I do know that that's -2, which means that's -4, and this side must be +4. I don't know why I'm writing 5 there. Let's try to change it. There we go. And the only way it's +4 is if that one single SN is +4. So that's the way it's got to be neutral. One SN had to be +4 to neutralize the -4 from the two negatively charged oxygens. And of course that was tin, and the O was oxygen, which turns into oxide without a Y. I'm losing it. I'm trying to go a little too fast on that one. All right, I don't know what happened there, but I'm back. 3 more to go. SB, well, we already saw it. It was antimony. We already saw it needs Roman numerals. Okay, it was up maybe 4 or 5 questions, so we don't have to look it up again. Needs Roman numerals. Okay, just before I forget, it was called antimony. And I is iodide. It's over here, right there, number 53. Iodide is -1. Boom. Okay, so -1. I have to investigate. It's -5 charge. It's a +5. Okay, the only way that works is if the SB is +5. And I is iodine, turns into iodide. Cu we've already seen once before. It's copper. Okay, actually we see it a few times here. It is right here. It needs Roman numerals. You can see it right here. The Cl is chlorine, turns into chloride. But what is the charge? Well, it's -1. Again, from what? From over here. All Cl's in ion form are -1. It's a known commodity. Which means I have a -2 charge. This guy has to be +2. Why? Because there's only one of them. So it's got to be copper 2. Copper 2 chloride. Last one. Keep this under 30 minutes. That's good. Au, we've seen before, it's gold. If you don't remember, it's right here. Number 79, Au gold. It's not colored green. It needs Roman numerals. So it needs Roman numerals. It's gold, Roman numeral. P is phosphorus, turns into phosphide. And what is that Roman numeral? Well, what is P? P is over here. It's -3. So if I go back and say that it's -3, then that means the overall negative charge is -3. The positive charge must be +3. And that means that each gold is +1, because I have 3 of them, right? +3, each gold must be +1. So it's gold 1 phosphide, right? So that's your tactic. Going forward to the formula, you take advantage of the scrap. Note I didn't use any scrap going the other direction, but going forward to the formula, I use the scrap every single time in order to find that neutrality spot, that lowest common multiple, and how to get there. Going backward basically is a test of familiarity with the periodic table of the elements. Okay, you have to be able to build whatever your teacher gives you. In this case, this is what I do. Some teachers give you a couple more ions to know. I don't. I just give you this. And you have to know, do I use Roman numerals or the stock method or not? And if you know the charges, if they're green, you don't use the Roman numerals or the stock method. If they're blank on here, they need Roman numerals. So you have to know that. You have to do that by comparison. How do you figure out the Roman numerals are? Again, those are the ones that you have to write and doodle on. I didn't doodle on these because I didn't have to do anything. I just had to know that Mg was magnesium and that N was nitrogen turns into nitrite. Didn't have to do any work. It should be like boom, boom, boom for those. You're going to find out that these are the ones to take a little bit more thought, but I'm confident, if you keep practicing this, this is something that you can figure out. Because you know what, it's only going to get more and more layers, more and more difficult. So this is the time of year typically when you're reading, you're learning ionic bonding, where you really, really, really have to stay up to date with the content and not fall behind. And hopefully, if you're watching this, you feel a little bit better about your ionic formula writing and naming skills up to this point at least. So adios, and I did cross the 31-minute mark, but you know what? 'Tis life. Sometimes it happens. 31 and 20 out.